guys, welcome back to Civil Mentors. In today's episode, we're diving deep into the world of building construction. As a professional civil engineer, I'll guide you through the key steps involved in bringing a building to life. Whether you're a beginner in the field or just curious about the different steps involved in building construction, this video is perfect for you. So buckle up and let's get ready to be amazed by the incredible process of turning ideas into concrete reality. Step 1. Land acquisition and site selection. The first and most critical step in building construction is selecting the right piece of land. As a civil engineer, we need to assess factors like location, accessibility, and the land's potential for development. A well-chosen site can significantly impact the success and appeal of the building. So always remember, it all starts with the perfect piece of land. Step 2. Site survey and soil testing. Once we have our land, it's time to gather essential information about the site. This involves conducting a detailed site survey and soil testing. A site survey provides information about the land's topography, boundaries, and nearby utilities. Soil testing, on the other hand, helps us determine the soil's load-bearing capacity, which is crucial for designing a safe and stable foundation. As a civil engineer, understanding the site and soil conditions is fundamental to the success of our project. Step 3. Design and planning. Now that we have our site information, it's time to collaborate with architects and other engineers to create a design that meets the client's requirements and complies with building codes and regulations. During this stage, engineers develop comprehensive architectural, structural, mechanical, electrical, and plumbing plans. This intricate process requires civil engineers and architects to use their technical expertise and problem-solving skills to ensure a safe, functional, and aesthetically pleasing building. Step 4. Obtaining permits. Before we can break ground, we need to obtain all necessary permits and approvals from local authorities. This step is crucial to ensure our project adheres to zoning regulations and building codes. As a civil engineer, it's essential to be familiar with local regulations and to work closely with authorities to ensure a smooth permitting process. Step 5. Site preparation. With all permits in hand, it's time to roll up our sleeves and prepare the site for construction. This involves clearing debris, vegetation, or existing structures and performing earthwork such as excavation and leveling. Proper site preparation is critical to ensure a stable and level surface for our building's foundation. Step 6. Foundation construction. Next up, the foundation, the bedrock of our building. A well-designed foundation supports the entire structure and transfers loads to the ground. As civil engineers, we need to consider factors like soil conditions, building load, and design requirements when selecting the appropriate foundation type. Depending on the soil conditions and building requirements, the foundation can be shallow or deep. It's fascinating how these hidden parts of a building play such a vital role in its stability and longevity. Step 7. Structural framework. With a strong foundation in place, it's time to erect the structural framework. This stage is where our building starts to take shape. The structural framework, which consists of columns, beams, slabs, and load-bearing walls, provides the backbone for the entire structure. As civil engineers, we need to ensure that the framework is designed and constructed according to the building's requirements, providing a safe and stable structure. Step 8. Masonry work. This stage involves constructing non-load-bearing walls using materials like bricks, blocks, or stones. Masonry work not only adds aesthetic appeal to the building but also creates separate spaces and functional divisions within the structure. As civil engineers, we must ensure that these walls are built to the correct specifications and comply with relevant building codes. Step 9. Roofing. Now that our walls are in place, it's time to install the roof. A well-designed and properly installed roof protects the building and its occupants from the elements. As civil engineers, we must consider factors like local climate, building design, and available materials when selecting the best roofing system. From asphalt shingles to metal sheets or tiles, roofing materials come in various forms to match the building's design and requirements. Step 10. Plumbing, electrical, and HVAC installation. Now that our building has taken shape, it's time to bring it to life with essential systems that make a building livable and functional. As civil engineers, we collaborate with specialized professionals to ensure the plumbing, electrical, and heating, ventilation, and air conditioning systems are designed and installed according to the building's needs and local codes. Step 11. Finishing work. Now it's time to add some flair with finishing work. Finishing work is all about adding the final touches to our building. This stage includes plastering or drywall installation, painting, flooring, and installation of fixtures and fittings. As civil engineers, we coordinate with various trades to ensure a high-quality finish that meets both the client's expectations and regulatory requirements. Step 12. Landscaping and external works. Our building's surroundings are just as important as the structure itself. Landscaping and external works involve creating beautiful outdoor spaces, planting trees, installing walkways, and constructing driveways and parking areas. As civil engineers, we work closely with landscape architects and other professionals to enhance the building's overall appeal and functionality. Step 13. Inspection and commissioning. Before our building is ready for occupancy, it must undergo several inspections to ensure compliance with building codes and quality standards. As civil engineers, we work closely with inspectors and authorities throughout the construction process to address any concerns and ensure a smooth final inspection. Once the building is deemed compliant, a certificate of occupancy is issued, and the building is officially ready for use. Step 14. Maintenance. Regular maintenance is crucial to ensure the building's longevity and functionality. As civil engineers, we develop maintenance plans and coordinate with building owners and facility managers to ensure the structure remains safe and comfortable for its occupants. And that's a wrap. We've explored the intricate process of building construction from a civil engineer's perspective. From land acquisition to maintenance, each step plays a crucial role in creating the incredible structures we see and use every day. If you enjoyed this video, be sure to hit the like button, subscribe to our channel, and share your thoughts in the comments below. Stay tuned for more insightful content on Civil Mentors. Until next time, keep learning and stay curious.